So today we're going to go over 5-1 notes. So we're starting a new unit all about exponential functions. We're going to be graphing them today. I'm going to split this up into two parts, so you're only going to be taking about half of the notes today because it's kind of long. I don't want you to have to watch like a 30-minute video. So if you remember before, you guys learned about linear functions, and when we had linear, our equation was y equals mx plus b. And now we have exponential functions, and that equation is over here, or that formula. So remember, in linear, we had m as the slope, and b was the intercept, and we had a pattern of going, of adding or subtracting. Right, you might go up 3, minus 3, whatever. But with exponential functions, our pattern is multiplying or dividing. So in this, the a is the y-intercept, and the b is our pattern of multiplying or dividing. So there's some things over here to the right that we're going to go over. So exponential functions are the product of the initial amount, which is our y-intercept, and a constant ratio raised to a power. So that's the b, that's the multiplying or dividing pattern. And they are modeled with this equation here, f of x equals a times b to the x, where a non-zero constant b is greater than 1 and b is not equal, or greater than 0 but not equal to 1. So that means that b has to be greater than 0, but it cannot be exactly 1. If b is greater than 1, then it is called exponential growth. If b is less than 1, it is called exponential decay. And that's going to be important to remember, because we're going to have to note that each time we're graphing it. And then we have asymptotes. So functions get really close to this asymptote, but they don't ever reach it or cross it. And that is represented by y equals c when we have plus or minus something at the end of our equation there. If we don't have anything, then it's just 0. And this is going to be horizontal. If you remember, y equals something, that's a horizontal line. So our asymptote will be horizontal. So let's take all of that and apply it to an example so it can make a little bit more sense. So we need to classify it as growth or decay, fill in the table of values, and graph it. And then we're going to identify its key characteristics. So here we have y equals 2x. If you want to go ahead and get out a graphing calculator or use something like Desmos, and you want to just type this in and see what it looks like, go ahead and do that. And you will see, just as like a small example, that our graph will go up like this. So it's kind of a curve that goes up, and that's what our exponential functions are always going to look like. They might go this way, they might go down for their decay, but it's going to be a curved line and not a straight line. So we're going to fill in our graph here. So let's do -2, -1, 0, 1, and 2. So you could put in your calculator 2 to the -2. But you remember when we were learning about exponents, if you put that into your calculator, sometimes you're going to get a weird decimal. So remember, 2 to the -2 is the same thing as 1 over 2 squared, which is 1/4, or 0.25. And then 2 to the -1 would be 1/2, or 0.5. 2 to the 0 is 1, because anything to the 0 power is 1. 2 to the first is 2, and then 2 squared is 4. So now let's graph this. So I'm going to start with my intercept here, my y-intercept. I'm going to graph that. So over 0, up 1, I just graphed this one. I'm going to go over to the positive now. Over 1, up 2. And then over 2, up 4. All right, now I'm going to go over to my negatives. Over -1, and then up just a half. Over -2, up just a fourth. So then we'll connect those and draw our line here. But I'm not going to ever touch or cross the x-axis because that is actually my asymptote. So at the end of this, we have, you could think of plus 0, and that's going to be our c. And so our asymptote is y equals 0. And we get this, remember, from our c. And we don't have a c, which means that our asymptote here is the axis. All right, let's go on to our y-intercept. So the y-intercept is found just how we do it in linear problems. It would be x equals 0. So to find the y-intercept, you do x equals 0 and solve. So if we were to put 0 in for x, what would we get? Well, we already did it. It's right here. So that's going to be our y-intercept. Over 0, up 1. Now we're going to do our domain and range. So the domain is all of the x values that we can use, and the range is all of the y values that we can use. So according to this graph, we can use any of the x values, right? We can put in any number over here, any number over here. So this would be all real numbers, and we write that as -infinity to infinity, because we can use infinite numbers for the domain. Now let's look at the range. That's the y values. So our y values are not infinite, right? We can't cross this x-axis here, and we also can't do anything below it. So our range is 0 to infinity, because we can choose any of these values that are positive. Now we can't choose 0 because that's on the axis. And so that's why we have these brackets like this, the parentheses, and not this. This would mean including it. So that's our first one. Now it's a lot to take in, so we're going to do these notes over 2 days. Let's go on to our second problem here, and we're just going to do the same thing. So I'm going to choose, -3, -1, 0, 1, and 3. Doesn't really matter what you choose, just don't do more than, what's on this graph here, so I wouldn't go more than 4. So if we were to put -3 in, we would have 1/2 to the -3rd. You can use your calculator for this, that's fine. When you do that in your calculator, you should get 8, and then plus 2, which is 10. Or you can use your graphing calculator and see the table of values that you get. So this is what we should get. And now let's graph it. So -3 up 10. Over -1 up 4, over 0 up 3, over 1 up 2.5, over 3 up 2 1/8. It seems like it's approaching 2, right? And that would be correct because that is our asymptote. So I'm going to draw this, but not touch that line there. So our asymptote, remember, comes from that 2, and that's going to be right here. So our asymptote will be y equals 2. Okay, let's look at our y-intercept. Remember, that means we set x equal to 0, which again we already did here. So that means that our y-intercept is over 0 up 3. Our domain and range, the domain is all real numbers again, and it will always be all real numbers for our exponential problems here. But the thing that's going to change is our range. This time, instead of going down to 0, we go down to 2. So 2 to infinity, right? We can't pick any of these numbers, but we can't pick 2, but we can pick anything above 2. And then, I forgot to do it on the first one there, we need to decide if it is growth or decay. So remember, to decide if it's growth or decay, we have to see is b greater than 1. And b is the number that is attached to the exponent. So, is b greater than 1 for the first one? Sure is, so it would be growth. Is b greater than 1 on here? Nope. So it would be decay because it's less than 1. Okay, we are going to do one more. We're going to do number 3 here, and we're going to save the rest for another day. So we're going to look at this problem here, and we're just going to write out the characteristics and not graph it this time. So is it growth or decay? For that, remember, we need to see is b greater than 1. b is the number that is attached to the exponent. Is it greater than 1? Yes. So it is growth. The y-intercept. You set x equal to 0. So we'd get 1, which means that our y-intercept is 0, 1. The asymptote, remember that comes from the c here, so y equals -1. The domain, as always, is all real numbers. And then the range. So what is it approaching? It's approaching the asymptote. What's the asymptote? -1. So our range is -1, comma, infinity. Now if you want to see what this graph would look like, it would be something like this, where our asymptote is at the bottom here at -1. And we know it's growth because it's going up. It's going up to the right. Just like this one up here is going up to the right. This one is going up to the left. Okay, so that is where we're going to end for our notes for today. Down here on the try these for your homework, I want you to just try number 1. So all you have to do is graph this problem, make a chart, graph it, and then find its key characteristics. And that is what is going to be due next time I see you.